start diameter is and what the end diameter is?
That nothing in nature is static. Everything is in motion, even we feel it or understand it. For example, aging is a motion, correct? Your body is always constantly in change, but it's the matter of the time that you understand the motion. Architecture is one of the interesting structure that during the construction, there is so much of motion, there is so much of machine helping in the construction, but at the time that the construction is finished, architecture becomes super static. The only elements of architecture that just move is a door, windows, very, minimum, and never change during centuries that we do the same type of, architecture. Although with all the development in the computation, in the fabrication, in even a smartness of material, we can move toward more, dynamic or transformable design. And not just, it has two ways. One is the emotional way that if you interact with things, you care about them more, it's more exciting for human being to, deal with something that has some emotion in return. And the other part is about the application and practicality, like environmental aspect or relationship between indoor, outdoor, and a lot of other aspects that I think motion can bring to architecture. One of the basic of motion are rigid bodies. And a rigid body means that the elements that is in the motion is solid, and all the motion happens from the pivot point or the sliding point. One of the basic structure that everybody knows is a scissor structure, and for this one, the straight elements has the same lengths, and the holes is happening in the middle, and you can go straight in or out, and that's the linear motion that you can provide. There's a good relationship between the geometry and final form. And one of the aspects of fabrication or being smart about fabrication method is how we can do no waste or less wasteful product fabrication method. And we were thinking about that, what's the property of the bamboo and having a round shape stem, and thinking that how we can form a structure that has no waste fabrication. And we figured out that, by cutting a circular section and rotating it 180 and putting it back, they're gonna match again because they are the same ellipse, and it rotate and make this one. And guess what this is? And this process of understanding the geometry, we collaborated with a mathematician from Oxford University, Alan Brody, and it was really nice to think about that, how we see the world in a geometry way, and he was thinking on a mathematics and understanding of the mathematics of and we made a platform that we could imagine any curve, how they can go and become part of a linear elements. So, and our goal is to fabricate a complex form out of one bamboo stem. And the last piece is the magic. Yes.
So in this case, it's quite straightforward for us to translate directly the 3D geometry into a physical object by 3D printing, because we don't have to really care too much about how it's being fabricated, how exactly the angles need to be. We can just directly export it from the software and print it as it is. Of course, we need to start rethinking a little bit the ways of how we fabricate it once we're out in the field, once we work in a workshop, and once we work with larger materials such as bamboo, and also account for some of the tolerances that come with natural materials. So since one of the main challenges is how we get the data that we create through computation into the actual physical geometry, we of course need to go back to design our own tools that allow us to translate these angles, these dimensions to the workpiece. Obviously, tools like robotic fabrication would allow to do us this in a quite precise way, but we also need to find ways how we can bring this out of the lab and also bring it into the hands of local carpenters that can manufacture it directly on site. So what you can see here is a very basic low-tech apparatus that allows us to choose the angle of the cut that we want to do, and it also allows us to choose the rotation of the piece that we are cutting. And therefore, with these two angles, we are basically creating the cut and the opposite cut. By rotating it, we can assemble it back to any angle that we want. And therefore, it allows us to create any three-dimensional curve based on a polyline.
On the detailed design is after you get these two pieces and you turn them and you find the proper, angle of orientation, how we can connect them together. So what we explore is what are the techniques that we can help us to assemble, and we figured out that if this is the angle of the cut and we have a holes over there, this is the angle of rotation, and you can put the pin over there, it hold it firm. And then with this slit and pressing something there, so we have compression and tension in the joint. And this is a more crafty details that is series of holes, and it has the weaving inside, and it's very looks very high crafted, more than and more two materials that they work together really well as well, although it takes more time.
The challenges that come through scaling up, and then still the pleasure of completing it in almost a better way than the scaled model worked. Like fully made of bamboo is, I'm kind of proud that we as a team there with the guys made this happen, and that also nobody wanted to go, and it's like, come on, it's time, like we have dinner, we have the circle, and everybody's like, no, come on, we need to finish this, which I really like personally, this motivation.
One thing that I like about it now is when you chose the pole, it's very unique, and now it still has, you can see that it's one, correct? And it is simple, I think, and that's the beauty of it, that there's so much complexity, but it become united. So I feel that I'm very interested to see how people interact with it, how they get their attention and how much they're gonna pay to understand that what is happening there.
And I love the spots you proposed over there, because it kind of creates through the snot almost like an entrance gate, which is a cool idea for the entrance of the dining area here.
So let's try and take some pictures of how does it look there.
Okay,
There.
Let's do it. Okay, let's go. It's not that heavy. That's the beauty of the baby. I think if the team become there, it's gonna be nice. You can see them. Okay, the first one is okay.
You went that way or rotating?
No, rotating. It's very heavy for me.
Rotating a bit more, no?
Yeah. Yeah. Are you there? You got it?
Yeah, I got
Yeah,
it. I got it.
Okay. We can
To twist it even more, no?
turn it like more, turn more. Yeah.
Okay, ready for the next one?
Yeah. Oh,
Okay.
other comes side. It's very heavy. There, the other one.
Where exactly?
Here.
Ah, here.